parallel lines here. So you can determine the pre-image and image of a translated line are parallel by calculating both of their slopes. So pre-image is the image before you have moved it. Translation is a movement. So it can be a slide, it can be a rotation, it can be a reflection. You've probably heard these words before, right? Translation is technically a slide. So if I translate it myself 2 steps, I would just slide 2 steps. Okay, normal translation there, image and pre-image. And then you can write an equation of a line that is parallel to a given line that passes through a point, and you can construct parallel lines today. So, a translation is a function that moves every point a constant distance in a specific direction. A translation can be described as a rigid motion, meaning it is moved directly as it is. It doesn't change the shape, okay? So, if you were to, when I move the desks, it is a translation, right? If I shift them all to the left so many feet, that is a translation. I'm sliding them over, which I need to do because you guys are becoming one big clump soon here. But that is a translation. So in this case here, you notice that we have a trapezoid, and it is being slid upwards, depending on which one's the image and the pre-image. So this one is the pre-image, and this one is the image. So notice it has that little 1 in the upper corner. That means that's the one that was moved. All right, so in geometry, parallel lines in a plane, parallel lines are lines in a plane that do not meet. We can create parallel lines by using a translation. So in this case, this translation moved from, do you see how it went from -3 to 1? So x was shifted 1, and y went from 2 to 0. So y was moved down 2. So in every case here, if I do -2 plus 4, that is 2. If I do 2 minus 2, that is 0. So do you see the translation here is just based on the points there? And you can see this. Let me give you A and A. So A's order pair is -3, 2. The translated one is 1, 0. So you can see -3 plus 4 is 1. 2 minus 2 is 0. So you see that shift of the points there? If you're looking at B, the original is -2, 2. -2 plus 4 is 2. 2 minus 2 is 0, which is where this point is here. So that's all that translation is saying, just to give you guys an idea of what's going on there. All right. When you're ready, go ahead and flip to the next page. So this is the pre-image. The pre-image is the image before it is translated. So the image before the translation. And I'm just going to call it f of x, just so we're calling our names by different things here. That's function notation if you can't remember that from last year. So it says create an image from the pre-image that translates all of the points x plus 2, x minus 2. So first of all, I would choose a couple points along the graph there. So give me So I'm going to put pre-image here. Give me 3 ordered pairs that are currently on our graph. So Sophia, give me 1 ordered pair that's currently on there. One. Okay. Give me another ordered pair, Hannah. I don't know if you can even see. Yes, there's another one that you can see. Dylan Deptula, give me another one. Thank you for switching that. It's x comma y, so it's 2, -1. Okay, so it tells us to create the image, you add 2 to the x, subtract 2 from the y, right? So, when we go ahead and do this then, you're adding 2 and subtracting 2. So, with that being said there, Melinda, what would my image point be for 1, 1 then? If you're adding 2, subtracting 2. So, it would be 1 plus 2, which is 1 plus 2, which is
3.
and 1 minus 2, which is okay, good. So again, we're adding 2, subtracting 3. So Landon, for 0, 3, what would that become?
That would become 2, 1.
Perfect. And Alana, we're adding 2, subtracting 2. So what would the other one become?
4 and then -9.
Okay, go ahead and plot those points to create your image. You need a straight edge. You should have a straight edge out anyways because we're going to be doing constructions. But if you need one, let me know and I'll get you one in a second after I get those plotted. So 3, -1, 2, 1, 4, negative. So I can't get that other one on there, can I? That's okay. As long as I have 2 points, I can connect them. Does anybody need a straight edge? Raise your hand if you would like a straight edge.
Or would straight edge?
There should be one. Anybody else want one? We pass that over to Melinda. Jerry. Anybody else? Pass that back to Ben. Do you want one too, Madison? Yeah. Isaiah would like one too? Pass those over there. In that direction, Madison wants one too. Isaiah, so if you have one to Madison, please. All right. So, tell me something that you notice, Jordan, about the pre-image and the image. So, I'm going to call this one F, and then I'm going to put a 1 in here of X, meaning the pre-image and the image, okay? So, F of X is the pre-image. That they're parallel, okay? So you notice that they're parallel, which means they're never going to meet, right? So we notice that they're parallel, so they're never going to meet. Hey, Dylan Deptula, what is the equation for the pre-image? What is the equation for the pre-image? Think y equals mx plus b. What is the equation for the pre-image? What did you say, sorry? Okay, be careful. Plus 3 is good. I understand where you got 1/2 from, but it's not exactly correct. So you're going -1, right, because you're going to the left and up 2. It's a rise over a run, not a run over a rise, first of all. So it wouldn't be 1 over 2, it would be 2 over 1, but it's also going downhill, so it'd be -2. There you go. So that's -2x plus 3. Anybody confused where we got that slope from? Dylan, do you understand what I was saying to you? Okay. And the 3 comes from the y-intercept. Okay, a little bit more challenging than that one is the image itself. Who can tell me what the image's equation is? Who can tell me what the image's equation is? That's that purple line on mine. That's the line you guys drew in. What is my equation for that one? What's our slope? Let's start with that. What's our slope of the image? Still -2x, right? It's -2. So how can we go about, so I'm going to do it this way, so that's down to right 1. It doesn't matter which way you look at it. How can we go about finding the y-intercept? What could we do? Yeah, Jordan.
How each point just go up to over 1.
Okay, so I go up to over 1. There's a point here. Am I on the y-intercept yet? No? Okay, I need to go up to over 1. And I would be on the y-axis. Who knows what point that would be if I'm on the y-axis there? Brandon?
0, 5.
How did you get that?
Because I did point slope.
Okay, because you just used point slope. Okay. So if you're here at 3 and you go up 2, where are you at then? 5, right? You went up 5. And if you go over 1, you're at 0, right? So that's 0, comma 5. Do you guys see that? Or, as Brandon said, just use point slope. Choose 2 points and use point slope. So, Cameron, what do you notice about these two equations? The pre-image and the image. The slope is the same. What's different? What's different? The slope is the same. Yeah, the slope is the same, but the y-intercept is different. All right. Are there questions on that slide so far? So what do you guys know about the parallel line slope? What do you guys know about parallel line slope then? It's the same with a different y-intercept. That's essentially what we just found here. Parallel lines have the same slope, different y-intercept, which you guys did learn last year. Whether it's still in that brain of yours or not is another story, but you did learn that last year. All right, so the pre-image and the image are given in a table. So Pablo decides to translate the image up 5 using the same x value. So create Pablo's chart and determine what you know about the pre-image and image and justify your answer. So it says use the same x values. So I'm going to rewrite my x values. And he's just translating it up 5. So up means y. So it's saying change the y by plus 5. Let's do that up here. That's what that's saying, right? Up is positive, down is negative. So it's saying do y plus 5. So Brandon, what would the y value for the first one go with? -1 now. There you go. Corey, it would become 4 what?
28.
Okay. Oh, instead I used the y instead of the x. Thank you for telling me now rather than when I got down there. Madison, why don't you help me with the next one? 5 goes with? Huh? 5 comma what now?
32.
Thank you. Lexi, 10 comma. Isaiah, 12 goes with. Perfect. Okay. So we have to see what we notice about each of these here. So I'm going to find the slopes of both of them. So this is increasing by 20 and this one's increasing by 5. 23 to 27 is 5. I'm just finding the slope, the change. This is 10, and this is 5. And then, so that's 8. And 2, is that what that is? So 20 over 5 is 4. Oh, this should be plus 4 here, not plus 5. 4 over 1 is 4. Did I do something else wrong? This would be plus 20. 'Cause people, tell me when I'm adding wrong. 20 over 5 is still 4. 8 over 2 is 4. So what is our slope here? What is the slope of the first one? The pre-image. What's the slope? So when you look at this originally, does it look like it's linear? When you first take a look at it, would you think it's linear? You notice that if you simplify it is linear though? So this was something that we talked about in Algebra 1 last year with you guys. It's like you really need to look at the slope at every single point before you decide if it's linear or not linear, okay? But this is linear, and it has a slope of 4. So let's find the slope of the other one now. So this is 20 and 5, 4 and 1, 20 and 5, 8 and 2. Is that the same as what we just did over there?
Yeah.
So what's the slope of this one? What do you notice about the slopes then? They're the same. So will this, so what do you know about the pre-image and the image then? What do you know about the pre-image and the image if they both have a slope of 4? They'd be what? They're parallel. Parallel lines have the same slope. So they are parallel because they both have a slope of 4. So we have a few more examples to do, and then we'll get into constructions. Again, your construction portfolio is due next Friday. You'll only have one more construction you're learning on Friday, so you can get some more of it done over the next couple of days if you would like. At the end of the hour, because we still have 70 minutes left in this hour, so an hour and 10 minutes. If you want to work on that and the homework, you can do both of those, and I can help you guys out, okay? If you need something. Does that make sense? Some of you guys could really use some help on this construction, so like while I'm available to you, that might be a really good time to ask, all right? All right, so we are going to determine if the lines are parallel or not. How do you determine if the two lines are parallel? What do you look for, Brandon?
Same slope.
Same slope, different y-intercept. Otherwise, it's just the same line. So to determine slope, it needs to be in slope-intercept form. So first, put it into slope-intercept form. Which is y equals mx plus b. Then you can compare the slopes. Okay. Cole. Get it, that first one there and that first line into slope-intercept form for me. What would you do first?
You would do y.
What would you do first to get 8x minus 2y equals 3 alone?
Oh.
You want to get into y equals mx plus b. You're trying to get y alone.
Subtract 8x.
Thank you. I think you were confused by my question. Then what would you do, Cole?
Then you would divide by -2.
So we divide all pieces by -2. And we get y equals 4x. Negative divided by a negative. -8 divided by -2 is a positive. Minus 3 over 2. So just getting that into slope-intercept form there. Tucker, how would you get x plus 4y equals -1 into slope-intercept form? Then what would you do, Tucker? Okay, so we found the slopes. We found slope-intercept form, so we can look at the slopes. Sophia, compare those slopes. Is this one parallel? Why not? Because they don't have the same slope. This is the symbol for parallel. Just so you guys are aware. It kind of looks like the number 11, right? So we would say, I'm going to use that instead of writing the word. So not parallel because 4 does not equal negative 1/4. Right? They're not the same slope. So that 11 there is not, it's not saying not 11, it's saying not parallel. So if you need to like make a note to yourself, you might want to do that. But I'm fine with you guys using the symbols. A little bit shorter than writing the whole word. Jordan, how about help me with, oh, that first one's already in slope-intercept form. Help me with the second one there.
You would subtract 2y from both sides.
You don't want to subtract 2y because then that would move y away. What do you want to do?
Divide by 2.
There you go. Sometimes when problems are really easy, we do really silly things. It's all good. Paige, are those parallel?
Yeah.
Why?
Because the slope is the same.
Yeah, yes, they're parallel because 3 is equal to 3. Their slopes are the same. Isaiah, how do I get 3y equals negative x into slope-intercept form? So I'm on this one if you didn't know. Yeah. The other one's already in slope-intercept form. Cameron, are those parallel? Why not? What are your two slopes? The slope is? And what is this one? So are those the same? No. So because negative 1/3 is not the same as 3. Okay, the first one's already in slope-intercept form, Hannah, so what about the second one? What would you have to do?
Add 5/7x to those.
Ben, are those parallel? Huh? Okay, so why are they parallel? What's your slope of the first one? What's your slope of the second one? Is negative 5/7 the same as 5/7? It's close, but it's not the same, right? So are they parallel? No. All right, questions on that one before we write some equations? Do you guys understand how to determine parallel and not parallel? Just be careful because signs can be tricky, like that last one was kind of tricky. You see the 5/7 there and you want it to be parallel, but one's positive and one's negative, which would be two different numbers on a number line. So be careful. All right. Then let's get to the next one, and then we'll do some constructions. So it says, write the equation of a line that contains 1, 5, and is parallel to f of x equals 3x minus 4. You did these last year. This is not new, okay? Just so you guys are aware. Not that it was always the best when you guys did these last year, but you did. The thing that's confusing about this is you guys want to use the equation for more than what it's needed for. The only thing you use the equation for is its slope. You don't care about any other piece of the given equation. You throw away the equation once you know its slope. Do you understand that? So like that negative 4 in there, the y-intercept, means nothing to you in this problem. All right? So the first thing you need to do is make sure it's in slope-intercept form. After it's in slope-intercept form, take the slope and throw away the rest of the equation. And then finally, you're going to use the parallel slope, the slope, parallel to your slope, and the point, and put it into point slope form. Which we talked about point slope yesterday, is y minus y1 equals m times x minus x1. Okay, so get that written down and we'll do our two equations. Just making sure everything's okay over there. All right, so go ahead and get that written down, and then we're going to do that first arrow there. Okay, page, you're going to help me with the first one. So it says, write the equation on a line that contains 1, 5 and is parallel to f of x equals 3x minus 4. Is that in slope-intercept form?
Yeah.
Okay, so your slope of that line is what?
3x.
No x, just 3, right? What's the parallel slope to 3? Page 3. Okay, so we're done with that equation. I used it, and now I'm throwing it away. I don't care about that negative 4. Do you understand that? Okay, now we're going to use point slope form, and this point given to us with this slope here in point slope form. So Corey, what is the point slope form equation I should write?
Y minus 5
Perfect.
equals 3
Times.
parentheses x minus 4.
Perfect. It goes in opposite. The y variable goes with the y. So 5 is y. So it goes with the y. It's opposite. So it's negative. X goes with x. It's opposite. So it's negative. And we use a parallel slope. And then we just distribute. And add 5. And we are in slope-intercept form. So notice they have the same slope but different y-intercepts, right? So that's what makes them parallel. Tucker.
If you do the distributive property, isn't it?
Yes, it is. Thank you.
Sorry.
Why are you apologizing to me? Thank you for telling me. Please do not apologize to me for correcting me. It is never anything that you're doing wrong, okay? That means you understand what's going on, and I appreciate it, okay? Either way, still, different y-intercept. Thank you, Tucker. I know some people get mad. I do not get mad, okay? Don't worry about it. All right, so it says write the equation of a line that is parallel to 3x plus 5y equals 3 into standard form. Oh no, this one says standard form. Who remembers what standard form is? Anybody? Brandon?
A plus b y.
Yes. There's a few things about this. A can't be negative. And A, B, and C can't be fractions. Or decimals. So first of all, Mariah, is this in slope-intercept form for us to even know the slope? No, so what am I going to have to do? Then what?
And divide by 5.
Lexi, what is the slope of that line then?
-3.5.
So what is the parallel slope to that? So we're going to use that. It doesn't give you a point to. Doesn't give you a point to use. Just 1 second. I'm going to give you a point. Let's say through, let me see, it's -3/5, so I want my x value to be divisible by 5. So we'll do 5, comma 1. So add through 5, comma 1, because it didn't give it to you. So Dylan Deptula, using 5, comma 1 and the slope -3/5, can you please write the point slope form equation for me? -3/5, yeah. Okay, so we distribute. You guys all know how to use the fraction button on your calculators after last year. I'm hoping your teachers like pounded that into you because we do that a lot in this class, I know. So that's -3/5 plus 3. And then it'd be y equals -3/5 x plus 4. Is that standard form though, guys? Is that standard form? Okay, x and y need to be on the same side, right, Madison? So what do you need to add?
X.
So add 3/5 x, right? So I get 3/5 x plus y equals 4. Is the a value negative? Is 3/5 negative? No. Is it a fraction?
Yeah.
How can I get rid of 3/5? What can I multiply everything by? So multiply all pieces by 5. And I get 3x plus 5y plus 20. All right. Get your compasses out and your straight edge. Well, equals 20, not plus 20, yes. Where that plus sign came from, I'm not sure. Thank you.